So what I'll be covering today is the impact of materials in general. So I won't be just touching on timber. To get a better context for where timber sits, I'll be talking also a little bit about steel and concrete and what some of the issues are between now and 2050 when it comes to the use of structural materials. So I'm not sure if you've seen this graph before, but it's really interesting, I think, that shows the trend of the proportion of impacts that comes from materials. So traditionally, if you use the Pareto distribution to see where the impacts were, most of the impacts would be in operational energy. So people would say 80% energy, 20% materials. But as our buildings are becoming more operationally efficient with better building efficiency,
Adam, I don't know whether you can hear me. I can't see the graphs. Have you shared your presentation?
I
just saw another comment about.
Thank you, David. That's good now, I assume, yeah?
Yes, David, that's working. I mean, Adam, it's working now. Thank you.
Fantastic. Okay, so this graph here just shows the proportion of impacts for materials compared to operational energy. And as we're moving forward, the operational carbon is going down at a fast rate, meaning proportionally the impacts of materials is increasing. So there will come a time in the next few decades where the materials are the highest proportion of impacts for most of our projects. And I think this is a really exciting time for especially structural engineers, because engineers might end up being the most important consultant really when it comes to sustainability in the future. So this is another graph just showing the cost of solar going down at an exponential rate, which is allowing for really efficient buildings for energy. And as you can see here, the operations are going down and materials is kind of staying the same, or in some estimates is actually increasing going forward. So at the same time, we need to find land or build houses for 2.4 billion more people. And as David mentioned earlier, a high proportion of that is going toward our cities. So in terms of what this looks like, in 2010, we got about 141 billion metres squared. We need in total 133 billion metres squared worth of additional housing. So that's a lot of structural materials that we need to find to house the next the growing population. So what that translates into is 500,000 Empire State Buildings, or if you're going low rise, 500 million two-story townhouses, as you can see here. So structural materials, it's something that we don't really think about in terms of our own consumption. Steel and concrete is growing at a very fast rate. Every single person on the planet uses about 200 kilograms per year of steel and about 1 ton of concrete per year as well. So we are very reliant on these materials at the moment, and the impacts of these materials are only just going to keep on increasing going forward the way things are moving. And I think the biggest difference when it comes to solving the problems when it comes to operational energy compared to embodied energy and structural materials, we're getting all the solutions for energy from the sun. So the sun, every single second of the day, it's giving us more energy than we could possibly handle. But when it comes to our materials, we only have the earth to actually source it from. So this is, I think, going to be where most of the challenge is in terms of sourcing our materials sustainably. And organisations around the world, they're beginning to incorporate embodied carbon into their longer term visions when it comes to sustainability. Historically, the focus has only been on energy, but right now they're incorporating embodied carbon into their definitions. So this is the Green Building Council's future focus. For their next set of rating tools, they're going to have 20% mandatory reduction for all 6-star Green Star buildings and 10% for any building that's 5 stars. If you look at the context when we're looking at other materials and what some of the solutions might be to getting to a low carbon future, I think the lowest hanging fruit, which we should all be looking at, is just simply designing more efficiently. So engineers, we're on the hook for risk, but material cost is only about 6% of the build. So we're always incentivized to put more material into the building that isn't always necessary. And this rate can go up to 50% more material than that's required from the design codes. So as you can see here, as we put more material into the building as an engineer, our risk goes down substantially. And when we account for the allowance for design changes and the payment structure I mentioned, there's a lot of wastage in terms of just materials that goes into our buildings. At the same time, this is one of the big opportunities, because if we think about utilizing much more computers to do the computations, this is where our lowest hanging fruit in terms of savings can be for our embodied carbon. I don't know if anyone's familiar with this, but this is Grasshopper, and I think this is going to be the future of computations for engineering. Here you can just design the logic that designs the building. So traditionally an engineer would just do hand computations for every single element. With this, you can utilize this to do the design for the engineer, meaning if the architect moves the pitch by just 1 degree, all the computations automatically update. And timber is in a very good location for this, because things like Grasshopper can speak very well with the CNC machines that cut timber for prefabrication to be able to deliver it on site. When we're looking at concrete specifically, it's 8% of the world's emissions. It's more than the cars on our roads, and we have a huge demand for it, and it's going to be difficult to replace in some elements. I've got this image here of the future train network of Melbourne, and a lot of these are new railway and new pieces of infrastructure that needs to go ahead. And on the right-hand side here is another big challenge we got, because every single time we bring someone closer from poverty to our standard of living, there's a lot more emissions associated with that. And, I personally feel uncomfortable if we allow other people to live in poverty, because they want to aspire to have the lifestyle we have. So this is one of the challenge in terms of the values that we need to balance moving forward. So looking at the chemical reaction of concrete, 32% of it is generated in the creation of heat to turn limestone into lime. And the big one here is that carbon dioxide is released in the chemical reaction. So that's 55% of the emissions. And it doesn't matter how much we optimize this process of creating concrete, there's always going to be 55% of the greenhouse gas emissions that's released. So for concrete, which is this big issue moving forward, there are two minor solutions. So we've got geopolymers and supplementary cementitious materials. But again, if we're using fly ash, and in Australia, especially Victoria, we've got a lot of fly ash sitting there, these also are non-renewable resources. So these can help to a point, but eventually we're going to run out of the supplementary cementitious materials here. And a similar story with steel. So with iron oxide, we use heat to release the oxides off the iron, and then that way CO2 is released again in the chemical reaction. So it doesn't matter how much renewables we use for the generation of heat, there's always going to be a minimum amount of CO2 emitted in the creation of steel, which again goes against our longer term goals of the Paris agreements, or also like the Green Building Council's new carbon roadmap and so forth. So with steel, there's no real significant solutions out there. There's one somewhat speculative, which is a very early technology, and that's using hydrogen to release the oxide from the iron. So then you use iron, and the byproduct's just water instead of CO2. So in my opinion, hopefully it gets there. But from a timber point of view, that might be if this goes ahead, this might be the only competitor for timber in terms of getting down to zero carbon. So I think it was important to look at steel and concrete, because as you can see, I think they're going to struggle with the solutions on offer to solve the problems. As Clarissa mentioned at the start, timber is the only resource that really can achieve the goals in their full complexity going forward. So if we come back to the chemical reactions of cement and steel, as I said, inherent in the reaction, we release carbon dioxide no matter how much we optimize this process and make it clean. With timber, the whole chemical reaction equation's entirely flipped. So we actually have CO2 mixed with water and sunlight, and then it's actually stored within the product. So, the weakness of steel and concrete is the strength of timber in terms of carbon in this case. And then the best part about it, it releases the oxygen that we breathe and a bit of sugar. So for the timber life cycle, if you think about, say for a softwood tree, if it grows for 30 years, then you turn it into a timber product, you're keeping that carbon that was stored for that 30 years into a timber product. And as a new tree is growing in its place, say for above another 30 years, which will be less than the design life of the building, and say if the building's there for 60 years, all of a sudden you've got 2 lots of carbon dioxide stored in timber products and a new tree growing in the same place. So you can see how it can be really net positive in terms of its carbon sequestration. And then during its use phase, and then toward the end, there's a few different options you can have for the end of life, which I'll be covering toward the end of the presentation. I think this graph is really important to understand the wider story. So on this green line here, I'm not sure if you can see my cursor or not, but you have an unharvested forest, so a tree that just sits there. As you can see, there's diminishing returns in terms of the CO2 that it stores as it grows. So after the 30 years, it really quickly grows, stores carbon dioxide. And then for the next 170 years after that, it kind of just sits there because the tree's in its full maturity. After 30 years, if you were to cut this tree and turn it into a timber product, there will be some emissions associated with the processing and so forth. And if you were there at 30 years, it wouldn't be a good look because you just got a tree that's been cut and the ground looks empty. Then after another 30 years, you have another tree, and then because it's a younger tree growing again, it's storing carbon at a faster rate. And then over the longer term, it clearly stores a lot more carbon. It's really important to understand that the whole use of timber, it's conditionally sustainable. So if you cut the tree down and then you change it to a road or some other form of agricultural use like beef, or in Indonesia, it's palm oil, then it's really one of the worst things you can do. Because if we go back to here, if we cut the tree down after 30 years and then don't replant it, and then it just stays at zero the whole way, as opposed to keeping on growing and storing more carbon dioxide from the atmosphere. But we got to understand that carbon dioxide is extremely important for the next few decades, but it's not absolutely everything. There are other values we need to maintain, like biodiversity and protecting indigenous land. And there's some land out there that hasn't been touched by humans ever, and we probably don't want to be tapping into that because it's got some great environmental benefits of having some of this land untouched. And this is why it's important to understand the stamps of FSC, Responsible Wood, PEFC, because they understand and they look at all these other values as well as the carbon story to make sure it's sourced sustainably, to make sure the product is doing net positive impact to the wider built environment. So if we look at softwood plantations and how renewable the resource is, we grow 30 to 40 meters cubed per minute, which turning into engineered wood products is 11 to 15 meters cubed per minute. So some iconic projects around Australia, Forte, for example, it would only take 1 to 1.5 hours to regrow that whole building. For 55 South Bank Boulevard, about 6 hours. For the Monash project in Frankston, about 2 to 2.5 hours. So we do have the capacity to grow our buildings at a very fast rate. Okay, so when measuring embodied carbon, it all comes down to EPDs. So if you're not familiar with this, this is a way of transparently identifying the life cycle of a product in terms of its overall impact. So you can get these for pretty much every material that you come across if that material is happy to be transparent about how they do their process. So WoodSolutions recently has done 6 EPDs on timber products. You got softwood timber, hardwood timber, particle board, medium density fiberboard, plywood, and glue lamb, both for softwood and hardwood. So on the right-hand side, you can see the different areas of impacts that the EPD measures. So there's 7 different ones based on your different values. You might have a value each one a little bit differently, but most people would see the global warming potential as the most important. So as you can see here, for Australian hardwood, the global warming potential is minus 670. So it's taken in 670 kilograms of CO2 per meters cubed. So looking at softwood in a little bit more detail. So from the forestry, so when you take the tree into a timber product, it stores 900 kilograms of CO2. But then there are some emissions when it comes to the processing of that product right up to the point where it goes onto the truck and onto the building site. So the kiln drying in this case is where some of the impacts go. And from what I understand, there are some potential improvements from the timber industry in this middle section here to make timber products even better and more sustainable and better for the environment. Hardwood, so it stores 1,200 kilograms of CO2 because it's got higher density, and all of this can be taken from the Hind calculator that Clarissa mentioned at the start. Then down to the very end, it also stores 700 kilograms when it's on the truck on the way to the building site. For softwood glulam, there's a little bit more in processing in the middle, in the manufacturing of the finger joining and the laminating and so forth. But it stores 600 kilograms when it's on the truck on the way to the site. And for hardwood glulam, with a little bit more processing, it's 400 kilograms of CO2 on the way to the site. So that was all up until the site. So the end of life is something that's really important to be considering. At the end of life, the best option, in my opinion, is to reuse the product in any way we can. So to reuse it, we actually want to be using screws and detail it and design for deconstruction. With timber, this means avoiding glues in some of the connections, which isn't always the case. So it's something that we can be doing a little bit more of. We can recycle and downcycle into other products, but it's still storing the carbon. We can put it into landfill. So there's pretty exciting research to show that after 30 years of sitting in the landfill, 95% of the carbon remains inside the product. So it kind of just sits there and keeps storing on carbon. But there is a little bit of methane that's released inside the landfill, but overall it basically just sits there, which is a really good story. And fourth, we can burn the timber to use as biofuel. So when we're using the timber, it's remember at the start of its life, it took in CO2. We are releasing CO2. It's producing energy instead of the grid. So for Victoria, we've got a dirty electricity grid. So it's much better than that in that case. But there will come a time when our electricity grid's clean and biofuel won't be a good option. Just look at the time. And I think one of the most exciting areas in terms of sustainability is the design for adaptability and construction reuse. So building on top of our existing buildings, as opposed to knocking buildings down and then doing the foundations and the ground floor and rebuilding from scratch, is a really exciting area, because timber is 1/5 of the weight of concrete, and all the concrete designed in our cities, it's designed to the 28-day strength. So after another year, there's 20% of additional strength gains in the concrete. And after, say, 10 years, there's 40% more gains in the concrete. So there's additional capacity in our concrete structures that have been sitting there for a while. And because timber is so light, all of a sudden we can build on top of these. And this gives developers the additional option. They can either demolish and start from scratch, or now they can really build on top with timber products. So Darramoo House, just a quick case study before we close it off. The reference building, if they went with traditional materials, would have released 1,100 tons of CO2 into the atmosphere. Using CLT and glulam, it only released 93 tons into the atmosphere. So that's a difference of 900 tons. And this isn't including the carbon sequestration benefits of CLT and glulam. So I think that's another area of opportunity for LCA practitioners. Currently, they're not all including carbon sequestration in their assumptions, which I think they probably could be doing from my perspective. So in summary, embodied carbon is becoming increasingly important. If you're in this area and if you're responsible for materials, if you're an engineer, you might be becoming the most important person in terms of sustainability. Not yet, but with a 10 to 20 year time frame, materials proportionally will be where most of the impacts are. And timber, as I've covered, and as Clarissa mentioned, it really is the ultimate renewable. If we are going to get to zero emissions, we can't just stop at energy. Once energy gets to such a point, everyone will be focusing on materials. And I think this is a really big opportunity for anyone in this area of timber. So thank you, everybody. And we'll move on to question time with Clarissa.
Hi. Thanks for that awesome presentation, Adam, and also yours, David. There's such an amount of incredible, useful case studies, data, research in there. I know a lot of people will be very keen to get hold of those presentations, and we will be sending them out to everybody after the webinar. So that was one of the questions. So that one's answered. That will be sent to you either today or tomorrow. Okay, so we'll start. We've got a few questions, and anybody who haven't submitted a question yet, please do so now, and we'll get to it. So, David, a question from you, from Linda Jordanson, is to get a biophilic effect, does the use of timber need to be in a natural or raw state, or does the use of coated timber have a similar effect?
No, coated timber would be fine. I think the most important, and the question alludes to it, is the timber actually has to be visible. But no, coating doesn't detract from it. Particularly, obviously, there are separate issues to the emissions that come from that, but that's probably a separate discussion, I think, completely. But no, as long as the timber is visible in its original form, then yes, the biophilic design effects are realised. Until recently, the tallest timber building in the world was a student residence building in Vancouver in Canada called Brock Commons. It's a great example of engineered timber, but sadly, from a biophilic perspective, it's a bit disappointing because virtually all of the timber is covered in fire protective plasterboard. So most people going into the building would have no idea that it's actually a timber building. And clearly, yes, they don't enjoy the benefits of biophilic design. Lots of environmental benefits that Adam alluded to that they get. So yes, in response to the question, as long as the timber is visible, biophilic design effects certainly apply.
And I'd just like to add on to that, David. I think the using plasterboard and the deemed to satisfy approach for our buildings, it's in some places it's the best way to go, but there are some emissions also associated with plasterboard. So when we do expose our timber, we do get the double benefit of not having those carbon impacts of plasterboard, but also the benefits of biophilic design, which is a really big deal, as you mentioned.
Right. Well, thanks, guys. We'll move on to the next question now from Peter Tonkin. He's asked, do products like Hempcrete provide a viable solution to concrete?
Hempcrete. I'm not sure what Hempcrete is, but for concrete itself isn't the problem. It's the Portland cement within the concrete. So if Hempcrete is using products that eliminate the use of Portland cement, then it is a viable solution for concrete. I'm not sure what materials, but I think that from what I understand, one of the best solutions is geopolymer in the short term, because that is 100% removal of the 100% removal of the Portland cement within the concrete as well. But yeah, I'm personally not sure what Hempcrete is.
I think the other issue is availability as well. I mean, one of the benefits for timber, particularly here in Australia, where we've got 134 million hectares of timber, of which 2 million are plantation, is availability. So, and I'm not saying for a second that timber's going to eradicate concrete and steel completely. That clearly is not going to happen. It's much more about using materials where they make sense. But certainly from a renewability perspective, and obviously Hempcrete is another such material, it's the ability to be widely used in a wide variety of applications, which timber clearly has. That is the major benefit, I think.
Yeah, I agree. I'm personally really excited. I'm hoping there are solutions that come for steel, concrete, and timber, because there is a place for all three materials if if we're going to really get to zero carbon. Because obviously, foundations and in the ground, you do need steel and concrete.
So another question that kind of relates to that is, can you guys suggest any good resources that compare the construction costs of mass timber with steel or concrete? I certainly know the WoodSolutions website. There's a huge range of technical design guides on there addressing that very question, but can you suggest anywhere else people could go?
Yeah, that's good timing with that question. There's a new cost guide coming out for with WoodSolutions that compares the traditional construction using concrete and then timber, and they've got a whole range of different case studies to look at and answer that exact question. So this will be coming out, I think, in the next month or two. So if you're on the WoodSolutions email list, then you will be notified when this comes out.
Yeah, correct. And in addition to that, implicit in that is the assumptions that are taken into consideration on things like you don't have to, obviating the requirement for scaffolding, for example, and being accurate about the amount of time, on-site construction time that is eliminated by the use of timber, and really understanding that. And a number of the projects that we talked on earlier on, Jordan Springs Library at the Dock, Daramu House, were all built, of course, by Lend-Lease. And they're learning more about timber with every building that they do. They're not the only one, but they're probably the major producer using timber at the moment in Australia. And certainly the major benefit is obviously in significant reduction in on-site construction time. But another one, which probably doesn't get quite so much attention, is the significant benefit in terms of occupational health and safety. I know that the first 3 timber buildings that Lend-Lease did were the only 3 that they had so far, certainly in Australia, where there were no lost time injuries on site. So there are direct financial benefits in terms of reduced construction time, but also additional benefits like OH&S, for example, reduced noise and traffic to site and all that type of thing. So it's a complex issue, but the reports that FWPA and WoodSolutions have provided are probably the best, give the best and most detailed answer to that question, I think.
Yeah, Ben Owen from Lend-Lease, he was speaking at PTech recently, and he said Lend-Lease are expecting about 25 to 30% savings in terms of overall program. And on some of their projects, they're spending up to $1 million a day. So you can imagine the savings are absolutely huge in that case. And there was, I can't say which developer, but there was a developer who mentioned for a really significant project in Melbourne that they're expecting a 5% premium in terms of rents by having exposed timber in their buildings, because it's obviously a point of market differentiation, as well as all the benefits in terms of productivity, and it just shows the sustainability. And I think especially tech companies who really want to brand themselves as sustainable and up with the times, they're really moving toward timber buildings as well as their material of choice.
Okay, great. Thanks for that, guys. So we've got another just under 10 minutes for some more questions. So just a quick one. Can you guys comment on a comparison of lightweight steel and timber framing? A comparison on the emissions and sequestered carbon numbers. Adam, perhaps that's one for you to start.
Yeah, so I don't have any rule of thumb numbers at the top of my head, but if you were to go and explore that, it's not too difficult to do. You just need to get EPDs for steel products. I'm sure that they're around. Actually, I'm not too sure, because you'll probably find that materials that don't show the best story, maybe they don't have EPDs, but there'll be some information out there where you can actually get the kilograms of CO2 per meters cubed, and then just do a quick number on the framing, and then compare that to the meters cubed of timber. And it's a pretty quick calculation. But just intuitively, I think if you just think back to that chemical reaction equation, it tells the story, so you can kind of preemptively understand what the difference is.
Excellent, great. All right. So I've got a question about, can you please give some more information on why you prefer the option to reuse recycling timber products rather than the landfill option? Is it to do with environmental or financial or other reasons?
That's a good question.
Well, certainly, timber is a valuable resource, both economically and structurally, and for a whole host of reasons, not least, the health and well-being that we've talked about. So, being able to use it, one of the benefits, particularly of engineered timber buildings, is that they are very systematically bolted together. And by definition, therefore, they can systematically be unbolted together. It's relatively straightforward, certainly by comparison to more conventional construction techniques, to actually disassemble a building at the end of its life and reassemble it either in its current form or in other forms. And that's by far and away the most environmentally as well as economically sustainable way to utilize the product, because, of course, great beauty of that is we're retaining the carbon storage. Now, I appreciate that, as Adam mentioned, yes, in landfill, research shows quite clearly that the carbon is retained within the material. However, if we're using it as in a recycled, and there's a lot of discussion now, of course, about the circular economy and the benefits of that, and timber has a very big part to play in that, and using materials as many times as we can for as long as we can. There are numerous, it's probably too complex to go into detail at this stage, but there are lots of calculations that have shown that that's by far and away the most effective and efficient thing that we can do. And I think timber's got a very big part to play in that, because it can be so readily disassembled and reused and reformed. I mean, if you don't use it in the same form, then compared to the energy that would be required to reform concrete or steel, reforming timber, whether it be sawing or whatever, or lathing, is relatively benign. So I certainly think timber's got a big part to play in that, in Australia and around the world, and as we move forward.
Are you guys aware of any specific research on design for deconstruction?
Yeah, I am. There's a great paper by Danielle Tingsley I think she's from the UK, and it's a good 120 pages that goes through design for deconstruction. It's, in my opinion, timber's definitely the best situated for it. If you think about composite steel concrete systems where you got shear studs, it's really impossible to use. With steel, as soon as you weld something, it's very hard to use at the end of life. So, but it's something that I think we're not doing enough of currently. When we build with timber as well, we want to avoid gluing things together as well. And if you think about between now and 2050, if we're actually going to get to somewhat zero emissions with materials, that means the buildings we're doing today has to be designed for deconstruction right now. So in 2050, we don't have to be taking more resources out of the ground.
Okay, great. Thanks for that. Just a couple quick more. We've got a question. Are we going to see more manufacturers around Australia for glulam and CLT, as freight is still a large component, particularly in Queensland? I'll just say we're very lucky that Hind Timber actually in the process of building a huge new glulam plant in Maryborough. So we're going to have a great resource, a great local resource for that. CLT, XLAM has a huge factory in Victoria, so obviously that is far further away. I don't think there's any other plans for any CLT manufacturers in Queensland. I was at a conference last week and saw that there's something under construction in Perth in WA. Mm-hmm. Are you aware of anything else?
Yeah. Sorry, go on, Adam. Over to you.
I was just going to say, I think we will see a lot more get into this space and a lot more competition moving forward, which is a good thing. I think it's going to grow the actual pie of timber construction in general. So there are huge opportunities there, and I think that just naturally there'll be more and more that pop up in that space.
I've actually seen some of the equipment manufacturer videos that show just a small business, a small local business can purchase something like a small truss and frame manufacturer, that they can actually create cross-laminated timber themselves. So it doesn't have to be a huge, great big construction. People can do it locally.
Yeah. And I think there'll be a mix of, as you're saying, the suppliers as well as the fabricators who, might get the product and then add to it and then bring that to site as well. So just another middleman in that sense, and who might value add with, windows and so forth.
Just to finish on, there's a question about how can we produce the additional timber required in Australia. I'll just address that. It is an issue. We do need more plantations in Australia. Hardwood doesn't grow well in plantations. It has been tried. So softwood is where we need to focus. The Australian federal government is supporting that. They've in the last election, they announced some concessional loans to help people, establish plantations, which is a very expensive exercise. So there will be more, but it does take a long time to grow, obviously. So imports will have to meet the demand because, it is the ultra renewable. People are going to use more timber. I think we should finish on the final question is, in terms of education of future generation of designers, where in Australia or overseas can timber-specific courses or degrees be found? If we want more people using timber, we do need to educate them. Adam?
There are quite a few universities around Australia right now. I know University of Queensland have got some specific courses. WoodSolutions as well is WoodSolutions Campus, which can help educate you in some areas. In terms of from my engineering background, I think it's lacking in some courses for engineering in terms of the undergraduate, but there are some universities where you can follow it for a master's. But feel free to contact me if you really want to educate yourself, or you got any other people, and I can give you a better answer by email with some specific places to go.
Yeah, there are University of New South Wales Faculty of Architecture teacher program together with Alex San is actually the designer of Dorome House. They have a facility, and UTAS in Tasmania in Launceston. They've been working with timber for a long time, and in fact they're just about to embark on a $350 million upgrade to the campus facility in Launceston, which is one of the biggest developments in Tasmania for many a long year, and that will be predominantly timber. So there are certainly a number of the educational establishments which are, there's not enough, we'd love to see more, but University of Queensland, University of New South Wales, UTAS among them, so there are definitely some.
Excellent. Well, thank you so much, Adam and David, for your participation today and for the support of Hein and WoodSolutions. I think we can say we've had a successful first webinar, the first of our 4 that we'll be running this year. Please watch your email for your for the copies of the presentations, and we'll also send out CPD certificates later this week, and perhaps a little survey so you can give feedback of what other topics you'd like to hear from us. So thank you very much. Enjoy the rest of your day. I think Adam needs a bit of a break. He's sounding a bit croaky there.
Yeah, I'm a little bit croaky. Thanks, Clarissa.
Thanks so much, Clarissa. Thanks, Adam.
Thanks, David. Thank you all for listening.
Talk to you soon. Take care. Bye.